This is me Arzu here and I welcome to you my channel Mr. Teeth, where your dental concept get dissected. This is our part 2 video of the enamel series, and in this video we will be dealing with total 5 topics, and these are ultra structure of the enamel. In that we will be studying with the enamel rods or the prisms, the rod sheath, cementing interprismatic substances or interrod substances. Okay, after that we will be studying about the cross-striations in next paper, and after that cross-striations we will be studying with the incremental lines of Retzius, also we call Straie of Retzius. Then after we will be studying with the Gnarled Enamel, and at last second last Schreger bands and the directions of the rod. Okay, so these are I think important topics of this chapter enamel, so you guys should focus properly in this video. So let's start today's topic without delaying much. So our first topic is enamel, and enamel it constitutes of the enamel rods or the prisms, rod sheath, and cementing interprismatic substances, also we call it interrod substance. Okay, so as we can see here I have written enamel rods or the prisms. It is also called enamel prisms too. Okay, now let's discuss about it. So it is a basic structural unit of the enamel. Okay, in longitudinal section it appears the cylindrical. Okay, so that also it's named enamel rod. Okay, as it appears in the longitudinal section as a cylinder shape, so that it is also called enamel rod or the prisms. Okay, now as I have told here, the basic structural unit of the enamel is enamel rod, and the basic structural unit of the enamel rod is crystals of the enamel. Okay, and that crystals is hydroxy apartheid crystals that I have discussed in my previous video of the enamel. Okay, so you guys have to watch that video first of all, then after you can watch this video, so you can relate both the videos. Okay, now in another point there I have written that number of enamel rod is 5 millions in the lower lateral incisor. Okay, lower lateral incisor there are 5 millions. That is the least number of the enamel rod present. Okay, similarly the highest number of enamel rod that is present in upper first molar, and that is 12 millions. Okay, so this is a bit important question for the MCQ purposes, MCQ questions. Okay, so it runs from the dentin enamel junction to the outer surface. Okay, as it runs from the dentin enamel junction to the outer surface. Okay, so let's draw a simple tooth here. So if this is a tooth, okay, and okay, so if this is a dentino enamel junction, okay, this is a dentino enamel junction here. Now okay, now so this enamel rods, they run from the dentino enamel junction towards the dentino enamel junction towards the outer surface. Okay, so in our next point I have written there the length of the most of the rod that is greater than the thickness of the enamel. Okay, so this point wants to tell us that if it is let us suppose if it is somewhat x micron, okay, thick, x mm thick. Okay, if it is x mm thick, then at that time the length of the most of the rod will be greater than x mm. Okay, so this means what, that the length of the rod, okay, so as we can see in this point, length of the most of the rod is greater than the thickness of the enamel. Okay, so I have told here if the length, okay, if the length of this enamel, if the enamel thickness is x mm, then the length of the rod will be greater than this x mm. Okay, it is because that there is an oblique direction. Okay, there is presence of oblique direction of the enamel rod. Okay, and there is wavy course. Okay, so the enamel rod, they runs wave. Okay, they run this in this pattern. Okay, they run from the dentino enamel junction towards the outer surface in a wavy pattern, due to is that the length of the rod is greater than the thickness of the enamel. Okay, so it is easy to understand. Now after that I have written the rod present at the cusp are larger than those at the cervical areas, as we know that the thickness of the enamel. Okay, this point I have also discussed in my previous video, that the thickness of the enamel is highest at the cusp or the incisor point, incisal edge, but it is less at the cervical edge. Okay, cervical region. So as if the thickness of the enamel is also less at the cervical region, the rods present at the cusp should be greater. Okay, should be larger than those at the cervical areas. After that, here we can see the area of the enamel at the surface is greater than the area of the enamel that is at the dentino enamel junction. Okay, so this point is also important, and it is due to the increase in a prism diameter near the surface. Similarly, the oblique orientation of the prism towards the surface. Okay, as I have written here, the diameter increases from the dentino enamel junction to the surface of enamel by 1:2. So the diameter of the rod, so the diameter at this dentino enamel junction, if it is x, then diameter at this, okay, should be 2x. Okay, so it increases in the ratio 1:2, so that as the diameter increases, so the area of the enamel at that surface should be increased. Okay, similarly there is oblique orientation of the prism. Okay, so this is also reason for the length of the most of the rod. Okay, so you guys should remember these 2 points, okay, for the length, and these 2 points for the area of the enamel. After that we can see here normally dimension of the each rod is Okay, generally it is in breadth it is 5 micrometer and in length it is 9 micrometer. Okay, so this is also important data that should be remembered. After that, I have written here the diameter it increases from the dental enamel junction. I have discussed with this point. Okay, after that, in cross section, when we visualize the cross section of the enamel rod, at the cross section, when viewed from the confocal scanning microscope. Okay, so sometimes they can ask in the viva, from which microscope will you prefer to see the cross section of the enamel rod. Okay, so confocal scanning microscope. Okay, so when we see from the confocal scanning microscope, it resembles normally like a fish scale. Okay, generally it like a fish scale. So in the fish scale, as we have seen the fish scale. Okay, so it is like this. Okay, so it has the body or head. Okay, it has a body or head, and this is a tail. Okay, so this is tail here. So this body. Okay, so the in head portion there is a rods. Okay, so there is a presence of the enamel rods or the prisms, and in the tail portion there is a presence of the interrod. Okay, so this is to be also remembered by yourself. Okay, after that, don't maintain the same outline throughout. So this point is also so important. So in this point we can see that here it is written that as I have told, generally there is a fish scale shape at the cross section of the enamel, but it is not maintained throughout the cross section. Okay, throughout different cross section levels of the enamel. Okay, it differs, as like near the dentin enamel junction it is arcade outline, and at the enamel surface. Okay, so in outer surface, enamel surface, there is keyhole outline. Okay, so it is quite similar with the fish scale, but there is a little difference between them. So we should remember this arcade outline is present near the dentin enamel junction, and the keyhole outline is present at the enamel surface. So let's move to our another paper. Okay, in this paper I have written that apatite crystals. Okay, so apatite crystals are arranged approximately parallel to the long axis of the prisms. Okay, so but deviation of up to 40 degree have been reported. So this point wants to tell us that, okay, let's discuss this properly. Okay, if this is a axis of the tooth. Okay, so enamel rods are arranged parallel to the axis of the tooth, but sometimes up to 40 degree of the deviation have been reported. Okay, so this is easy to understand. After that, I have written the dark lines on the enamel rod divide it at the 4 microns. Okay, so we will be dealing with this dark line in detail. These are primarily cross striations on the enamel rods. Okay, so they are at 4 microns. Okay, interval. After that, we can see here the crystals are oriented parallel to the long axis. Okay, of the bodies of the rods and fan out at an angle of approximately 65 degrees in the tails of the rod. Okay, so this point also wants to explain us that, as I have told, at the interrod in this paper, as I have told here, in the tail portion there is presence of interrod, and in this portion there is presence of rod. Okay, so the deviation of up to 45 degree is present. 40 degree have been reported. Okay, so the angle that is made by the interrod with the rod is 65 degree. Okay, so the tail it will make the 65 degree angle. Okay, so this is also important for the MCQ purpose. After that, we will move towards the interrod. In interrod, there is a presence of the they are present between the rods. Okay, so they are present between the rods, and they are oriented in a direction different from those of making of the rod. Okay, so if this is a rod and outer circumference. Okay, so this is interrod. Okay, so if this is interrod, I will show you another color. So let's think that this colored portion in the rod and this outer concentric portion is the interrod. Okay, so this is interrod. So in this interrod, those enamel rod that are present in this interrod are in different direction from those enamel rod that are present in the rod portion. Okay, rod portion. So we can see here there is a different from those making. There is a different in direction of the rods in the interrod in the circumference of the 3/4. Okay, so 3/4 portion of the circumference of the interrod have different orientation of the direction, but in 1/4 there is a same direction orientation present. Okay, so in 1/4 there is a same orientation present. Okay, after that we can see I have written the rod sheath. So rod sheath are primarily organic materials that surrounds the rod. Okay, so let me show you this by black color. So if this is rod and rod is surrounded by this black color. Okay, and then after there is presence of the interrod. So this black color is primarily the organic material. Okay, so surround each rod, and boundary between the rod and the interrod enamel is delimited by the narrow space containing the organic material. Okay, so we have completed the ultra structure that constitute of rod, interrod and the rod sheath. After that, we will deal with the cross striations. In cross striations, as I have told here, dark line on the enamel rod divides it at a 4 micron. Okay, so in cross striations, as I have written here, we can see the enamel rods are segmented by a dark. Okay, dark will be better term than the black. So dark line. Okay, enamel rods are segmented by a dark line. Those dark line are called cross striations. Okay, so they demarcate the rod segments and become more visible in the mild acid. Okay, so this you can remember. Okay, so if the enamel is acted upon by the mild acid, at that time they demarcate properly. Okay, so the rod segments are demarcated properly at that time in such a situation. After that, I have written it is more pronounced in insufficiently calcified. Okay, insufficiently calcified enamel. So this is also important. Now after that, we can see here it actually reflect. Okay, cross striations, cross striations are present because of primarily these 3 points. Okay, so in the first point, mainly the main important thing that cause the cross striation is diurnal rhythmicity in the rod formation. Okay, so as we know that enamel is formed by the enamel matrix deposition, and that is followed by the mineralization. So this represents the diurnal rhythmicity of the rod formation. Okay, so the rate of formation of the human enamel is a 4 micron per day. In one day there is a formation of the 4 micron thickness of the enamel, and that represents the diurnal, that represents the cross striation formation. Okay, after that we can see here there is organization of the crystals within the rod. Okay, so it is also may be formed by the organization of the crystals. Okay, crystals in the rod, as the crystals form the rod, so the organization of the crystals may form the cross striations. After that, we can see here this structural interrelationship between the interrod enamel. Okay, so structural interrelationship between the interrod enamel. Okay, so I will show you one pictures dealing with those points. Okay, so let me show you. I will take few minutes. Okay, so okay, so as we can see here, so I will show you first the pictures of the enamel rod in cross section. So in a transverse section, sorry. Okay, transverse section and cross section. Okay, so here we can see that it appears like a fish scale. Okay, so this is a body portion and this is a tail portion. Okay, body portion and this is a tail portion, so they are like similar with the fish scales. Okay, so here we have written keyhole shaped enamel rod, that is similar with the fish scales head, and there is tail and the rod sheath. Okay, so this darkish brownish line that is present, okay, that is delimiting the rod. So okay, so they are the rod sheath. Okay, that constitute the organic component. Okay, organic materials are present at that rod sheath. After that, okay, this is gnarled enamel, Straie of Retzius. Okay, so this is longitudinal section. In longitudinal section, we can see here that okay, the enamels are, okay, so enamel rods are present. Okay, here enamel rods are present here, and the darkish okay, darkish lines are dividing the enamel rods into different segments. Okay, different segments. So those darkish line we call cross striations. Okay, and this accentuated, okay, so pronounced dark lines are, so this more darkish line that are running through this through the thickness of the enamel, those darkish lines are called Straie of Retzius. We will be dealing with this later. After that, we can see here cross striations. Okay, so these are cross striations. This is dentine enamel junction and this is dentine. Okay, so now we'll study about the incremental line of the radius. So it is one of the most important topic. Okay, so in this enamel chapter, after that we can, okay, first of all let's see incremental line of the radius. It is also called the Straie of Retzius. Okay, this is hypocalcified structure. Okay, okay, so they are the hypocalcified structure. They are pronounced cross striations. Okay, so they are particularly pronounced cross striations, and they reflect the periodic bending of the enamel rod. Okay, so periodic bending of the enamel rod would may have formed this incremental line of the radius. Okay, so the people thinks that similarly there is a variation in the basic organic constituent. Okay, so variation in the basic organic structure would also have caused this formation of the incremental line of the radius. Similarly, the physiological classification, calcification rhythm. Okay, so physiological calcification rhythm would may have also caused this incremental line of the radius. So just remember, periodic bending of the enamel rod, or the variation in the basic organic structure, or the physiological calcification rhythm. Okay, now in another point, as I have written, in the longitudinal section and the cross section, okay, or transverse section. So in longitudinal section we just see as a series of line, as I have shown in the figure. Okay, I will show you picture once again. So in this figure, as we can see there, they are running as like a lines, okay, from the dentine enamel junction towards the enamel surface throughout the thickness of the enamel. Okay, so they runs like a series of line in the longitudinal section. Okay, so at the incisal edge, okay, this is to be remembered, incisal edge and the cusp, it surrounds the dentine. Okay, incisal edge and the rods, it surrounds the dentine. I will show you one picture. Okay, so see here. So this is an incisal edge. Okay, so this figure wants to say that this is an incisal edge. Okay, this is a cusp edge, and so at this cusp edge we can see that it is surrounding the dentine. Okay, it is surrounding the dentine. So this is to be remembered. This is also picture of longitudinal section, and previously that I have shown you. Okay, so this is also picture of the longitudinal section, but it is present at the cervical region, and this is present at the cuspal region. Okay, so just remember, it surrounds the dentine at the incisal edge and the cusp. Okay, an oblique line extends from the dentino-enamel junction to the outer surface. Okay, so series of line is present at the cervical region. Now in the cross section, as we can see here, it appears as a concentric lines. Okay, so it appears as a concentric lines. Okay, concentric rings. Okay, so this appears as a concentric rings. After that, it is evenly spaced. Okay, evenly spaced Straie of Retzius represents the 6 to 11 days rhythm of the enamel formation. Okay, so this is to be also remembered. Okay, it represents the 6 to 11. Okay, sorry, 6 to 11 days rhythm of the enamel formation. After that, here I have written, well, other Retzius lines are suggested to be due to the stress. Okay, so evenly spaced. Okay, so Straie of Retzius that are present at a particular interval, and so those Straie of Retzius are representing the 6 to 11 days rhythm of the enamel formation. But those who are not evenly spaced, okay, so they are suggested to be due to of the stress. Okay, now after that I have written a note for the incremental line of the Retzius here, that it is mean daily rhythm of the enamel formation of about 3.5 micron, increases from the inner to the outer enamel and decreases from the incisal region to the cervical enamel. Okay, so this point is not so important, but also you can remember it. It is simple to understand. It increases by 3.5 micron daily. Okay, increases from the inner to outer enamel and decreases from the incisal region to the cervical enamel. Okay, so after that we can see here, as I have written, 25 to 30 enamel, 25 to 30 incremental lines. Okay, they do not reach the surfaces. Okay, after that, during the abnormal condition, there is a broadening of the incremental line. Okay, so they can ask, okay, in abnormal condition, what changes we can see in the incremental line of the radius. So we can say that there is broadening. Okay, broadening of the incremental line of the radius. After that, we will be discussing with the gnarled enamel, and the gnarled enamel is a favorite question of every examiner. Okay, so in a gnarled enamel, as I have written here, so incremental line of Retzius was the hypocalcified structure, but this gnarled enamel is a hypercalcified structure, and they are present over the cusp. There is a complicated arrangement of the rods. Okay, at the cusp, that is called gnarled enamel, and enamel rods are more wavy and irregular and intertwined with each other in the region, especially to the dentino-enamel junction. Okay, so this wants to tell us that, so I will show you the picture of the gnarled enamel. So as we can see here at the cusp tip, okay, so this is a cusp tip, and at the cusp tip we can see that here is an intertwining of the enamel rod. Okay, near the dentino-enamel junction. Okay, this is not present here. Okay, this is present near the dentino-enamel junction. So you should remember that enamel rods are the more wavy and the irregular and intertwined. Okay, intertwined with each other in a region, especially to the dentino-enamel junction. Okay, now they make the enamel stronger at that point. So it is one of kind of the adaptation of the enamel to resist the masticatory force. Okay, so it makes the enamel stronger at that point. After that, we can say it appears like darkish cottoning appearance is there. Rods are arranged radially in the horizontal planes, and each plane surrounds the longitudinal axis of the tooth like a washer. Okay, so this point wants to tell us that, okay, so rods are arranged radially in the horizontal planes. Okay, so rods are arranged like this. Okay, so rods are arranged radially in horizontal planes. Okay, but each planes are surrounded by the longitudinal axis of the tooth like a washer. Okay, so in longitudinally every planes are surrounding. Okay, so rods are arranged radially in the horizontal plane, and each plane surrounding the longitudinal axis of the tooth like a washer. So in vertical axis, longitudinal axis, they just surround this enamel rod like a washer. Okay, so like washer, they just surround them. Okay, so this is not quite important point to be remembered, but also you can remember that rods are arranged radially in a horizontal plane, and the planes surrounding the longitudinal axis of the tooth is like a washer. Okay, now there is a back and forth undulation of the rods in the vertically directed rods around the ring of the small circumference readily explains it. Okay, after that, okay, after the gnarled enamel, we will be starting with the Hunter-Schreger band, and in Hunter-Schreger band, as I have written here, it is a quite of optical phenomenon that is produced by the changes in a direction between the adjacent groups. Okay, so the groups constitute of 10 to 13 rods. Okay, note, so this you may be having confusion in this, that Hunter-Schreger bands are formed due to the variation in the changes in the, okay, changes in the directions between the adjacent groups of the rod. Okay, not a single rod. Okay, so this point you should clear that from now onward, that there is a presence of the groups of a rod, not a single rod. Okay, Okay, so after that I have written they are the band which appears as a dark and the light of varying width observed in an enamel when a longitudinal section is viewed under the reflected light. Okay, so this point is also important. So you just remember that in reflected light there is a appearance of the Hunter-Schreger band, but in transmitted light there is no presence of this. There is absence of the Hunter-Schreger band. Simply after that we can see here I have written it arises from the dentin enamel junction to the inner 2/3 of the enamel, okay, thickness, and in the outer 1/3 rods are straighter. Okay, so I will show you the picture. So in this picture as we can see here, okay, so this is a Hunter-Schreger band. In a Hunter-Schreger band, okay, this is a Hunter-Schreger band, okay, dark and white band, dark and white band, dark and white band. Okay, so this is formed in enamel under the reflected light. Okay, so we can see that it arises from the dentin enamel junction to the inner 2/3 of the enamel thickness. Okay, so this thickness of the enamel is inner 2/3, and this outer, where there is absence of Hunter-Schreger band, that is the outer 1/3 of the enamel. Okay, and there also it had been written that slightly curved with a convexity toward the cervical region. Okay, so we can also see the convexity present here. Okay, convexity, okay, and that is directed toward the cervical region. Okay, now in another point, when section is cut, okay, those groups of the rod, okay, this point is important to be understand that, and I will try to clarify this point in easy way. So in the section, when the section is cut, those groups of the rod, okay, that aligns parallel to the light beams. Okay, so just think, so this is a light beam. Okay, so this is a light beam, and this is a group of the enamel rod, not a single enamel rod, okay, group of the enamel rods, and that is aligning parallel to the light beam. So in this condition, okay, parallel to the light beam, in this condition they reflect light away from the microscope, and there appears the dark zone we call diazones. Okay, D for dark and D for diazones. Okay, it is easy to remember. Similarly here I have written less parallel to the light beams. Okay, less parallel means it can be like this, it can be like this, it can be like this. Okay, so it can be at any angle with the enamel rod. Okay, with the in light beams. Okay, so those enamel rod that are not less parallel or not parallel, okay, they are less parallel or not parallel with the light beams, so those groups of the enamel rod will reflect light through the microscope, and they appear as the bright zone, and they we call parazones. Okay, and the angle between this, okay, so angle that is formed between this dark zone and the parazones is quite a 40 degree. Okay, so you can remember angle that is present, okay, between this light zones and this dark zones is 40 degree. After that also there is another opinion, and that opinion tells us that dark and light zones may have been formed due to the zones having different permeability, organic components, and the area with the variation in the calcification. Okay, so this point is also important. So they can ask you in the viva that how is Hunter-Schreger band is formed. Okay, so you can explain by this way, and if they ask tell me the another group of opinion, then we can say that it is formed due to the difference in permeability, organic components, constituents, and the area with the variation in the calcification. Okay, so permeability, calcification, and the organic component, and it is best seen in the longitudinal ground section under the oblique reflected light. Okay, so it is best seen in the longitudinal ground section under the oblique reflected light. And our last topic of today's video is direction of the rod. Okay, so in the direction of the rod, as I have written, they are normally, okay, generally they are perpendicular to the dentin. Okay, so the rods are perpendicular. Okay, here is perpendicular, here is perpendicular, here it is perpendicular, here it is perpendicular. Okay, normally they are perpendicular, but okay, in permanent dentition, as I have written here, and in deciduous dentition, I have as I have drawn here. Okay, so this is important to be remembered. Okay, so this is very important, I think. Okay, so in permanent dentition we can see the direction of the rod, okay, at the cervical point, okay, cervical region, it is directing towards the, okay, apical region. Okay, so at down of this tooth, okay, below this crown of the tooth there is a root, and this the rod that is present at the cervical region, that is directed towards the apical region of the root. Okay, similarly as we go upper than the cervical region, there is a horizontal placement of the enamel rod. Okay, and similarly as we go upper than that, there is presence of the oblique orientation of the enamel rod, and finally at the cusp there is a perpendicular or the vertical orientation of the enamel rod. Okay, in here we can see in the deciduous dentition there is presence of the vertical at the cusp, okay, oblique at the below it, and similarly horizontal below it, and also horizontal, okay, also horizontal below it. Okay, so in cervical region it is directed apically, but in cervical region of deciduous dentition it is directed horizontally, okay, not apically. Okay, so this is to be remembered properly. Okay, Now, as I have written here, okay, so these 2 points are not so important, but I will decide them. Presence of the alternating clockwise and counterclockwise deviation of the rod from the radial direction can be observed. Okay, so this point is to be remembered by yourself. Okay, by yourself. So there is a presence of the alternating clockwise and counterclockwise deviation of the rod is present. Okay, so there is a deviation alternating clockwise and counterclockwise deviation of the rods are present from the radial direction. Okay, and if the disc is caught in an oblique plane, okay, so when we see in oblique plane near the cusp edge, bundles of the rod intertwine more irregularly and form the gnarled enamel. Okay, so these 2 points are talking about the direction of the rod, and about the gnarled enamel I have talked previously in this video only itself, uh, in this video itself. Okay, so as I have completed all those topics of today's video, so if you this video, please do like, subscribe and share with your batchmates. Okay, so today's video was very important. Okay, so the point that I covered in today's video are very important for your board exams and also for your viva exams. Okay, so for the notes of this video you can visit my telegram channel. Okay, so there I have placed all the notes of my previous videos of this channel. Okay, so you can get the notes of every videos, okay, in my telegram channel, and also you can follow me in Instagram and Facebook. Okay, I have pages in both the platform. So this was for today. Tata, bye bye, thank you.